Picture yourself standing on the bridge of a nuclear-powered aircraft carrier in the middle of the ocean. It is early morning, and the sun is barely up when the radar operator identifies a surface contact. An Iranian warship is accelerating and pointed straight at you, coming right down your throat without warning.
It is playing chicken with 100,000 tons of American steel, as no radio response is received.
What happened next shows exactly how modern naval warfare works when nobody wants to start World War III.
Let us break it down beginning at 5:17 in the morning while the carrier operates in waters.
The carrier was doing routine flight operations and presence patrols when the search radar picked up something.
The ocean is a busy place, but this contact stands out as the bearing tightens in speed.
When a vessel goes from cruising to pushing hard, and someone made the decision to deliberately push forward.
The distance is dropping, and the computer calculates that this ship is aiming directly for the carrier.
Standard procedure involves hailing them on bridge-to-bridge radio with professional calm to ask their intentions.
They receive only radio silence because silence is a choice and a message that says, "Watch us."
The classification comes through as an Iranian warship, changing the context for the carrier strike group now.
The Iranian ship keeps accelerating toward 24 knots, locked on a dangerous collision geometry with steel.
The carrier holds its line because course changes are messages that show uncertainty in naval tactical encounters.
We are inside the range where mistakes become incidents and international news that nobody can walk back.
The Iranian ship's search radar comes alive, measuring and calculating the carrier and the surrounding escort vessels.
Through the optics, you see crew members repositioning with hands resting near equipment as the gun shifts.
The forward gun shifts just enough to be seen in the language of naval confrontation and signals.
No guns rotate on the American side. Only documentation, sensors, and cameras recording every single maneuver now.
Modern naval power is about who controls the narrative, and the narrative is built from recorded evidence.
The distance keeps collapsing, and the Iranian ship is now well inside the zone of non-coincidence.
The ship is doing 26 knots, burning fuel and options, while remaining locked on the carrier.
Rotor wash rolls across the deck as it lifts off to observe from a low offset position.
At 5:38, the non-lethal laser designator activates, settling a green point on the bridge. Suddenly, there is a green dot on your window, meaning we can touch you anytime we want.
You are operating in the unsafe area.
Please divert your course immediately. شما در منطقه ناامن فعالیت می‌کنید.
Figures on the bridge shift, and someone turns away as the encounter compresses to who blinks first. At 5:42, the wake shortens noticeably, and the bow dips as the throttle eases back. Crew members shift back from the rails in careful face-saving moves to back down without looking.
The first lateral adjustment comes as the Iranian ship starts drifting off the carrier's center line now.
They are conducting routine patrol operations in proximity to waters.
The American response is immediate, stating, "You are in international waters and actions are being recorded today."
By 5:48, the danger has passed, and the helicopter gets the signal to withdraw home.
On the Iranian ship, a figure raises an arm in a wordless acknowledgement of the encounter today.
The warship runs a steady parallel course, and no longer pressing or testing the carrier group anymore today.
To an observer, nothing happened, but the work of reconstructing the entire timeline is just beginning now. Every radar sweep is aligned with optical footage, and every communication is logged against maneuvering data today. The story is assembled without adjectives, as facts speak for themselves about the Iranian warship's aggressive acceleration.
In the narrow space between signaling and shooting, discipline decides everything, not firepower or the total size.
Being seen and recorded can be more binding than being threatened in modern naval power encounters today. Subscribe for more military analysis that goes beyond the headlines, and tell us what you think now.
The industrial production of naval steel begins with massive ingots being forged under thousands of tons pressure.
Robotic welding increases the speed and structural integrity of the hull sections for modern naval warships today.
Machining complex components for radar systems requires extreme precision to ensure peak performance in the open sea. Fiber optic sensors are the nervous system of the ship, providing high-speed data during intense confrontations. External camera housings must withstand the brutal pressure and corrosion of the saltwater environment for long missions. Calibrating laser systems ensures that the green dot remains steady and accurate on target bridge windows today. Terabytes of data from every encounter are stored in secure servers for later analysis and narrative control. Heavy lifting cranes move massive engines into place during the industrial assembly of a modern naval vessel.
Applying specialized anti-corrosion coatings protects the steel hull from the harsh effects of the open ocean.
Every watertight door must pass rigorous cycles of mechanical testing before being installed on a carrier deck.
Inspecting optical lenses for any microscopic defects ensures that surveillance footage remains crystal clear in the field.
Manufacturing miles of electrical harnesses is a critical step in powering the systems of a nuclear carrier.
Curing composite materials in industrial ovens provides the strength needed for helicopter rotors during intense flight operations. Testing armor resilience ensures the ship remains safe during the narrow space between signaling and real shooting.
Programming industrial robots for delicate tasks ensures that the ship's electronics are maintained with perfect precision.
Propulsion testing ensures that the carrier can maintain its heading, even when being tested by smaller warships.
Packaging communication equipment into reinforced crates ensures it arrives safely at the fleet for immediate deployment. Laser scanning finished propellers ensures they operate without vibration while the ship is maintaining 40 knots speed.
Industrial chemicals are synthesized to maintain the clean and professional appearance of the carrier and its deck.
Calibrating digital sensors ensures that every emission is logged with high accuracy during a naval encounter today. The final integration of the bridge superstructure is a monumental task requiring coordination of hundreds of workers.
Producing durable safety apparel is essential for protecting the crew during the intense high-pressure flight operations.
Testing automated ammunition loading systems ensures that the ship's guns are ready if the situation escalates today. Connecting high-speed data networks allows for the real-time sharing of surveillance footage across the fleet. Purifying fuel in industrial centrifuges ensures that the engines run smoothly during high-speed naval maneuvers today.
Radar calibration is essential for maintaining accurate surface searches even in the middle of the dark ocean. Testing the strength of mooring lines ensures the ship can be safely secured in port after mission.
Applying stealth coatings requires a precise industrial process to minimize the radar cross-section of autonomous aircraft. Capacitors for directed energy systems are inspected to ensure they can hold the necessary electrical potential today. Thermal inspections ensure that the reactor's insulation is functioning perfectly to maintain safety and peak efficiency now. Scanning every crate in the logistics chain ensures that space parts are always available for the fleet.